Hello everyone. So this is the lecture of design and maintenance of greenhouse. Okay. So this is Prof.A.R.Shinde will start the lecture. Okay. So introduction. A greenhouse is basically the purpose of providing and maintaining a growing environment that will result in optimum production at maximum yield. The agriculture in the controlled environment is possible in all the regions, irrespective of climate and weather. It is an enclosing structure for growing plants. Greenhouse must admit the visible light portion of solar radiation for the plant photosynthesis and therefore must be transparent. At the same time, to protect the plants, a greenhouse must be ventilated or cooled during the day because of the heat load from the radiation. The structure must also be heated or insulated during cold nights. A greenhouse acts as a barrier between plant production areas and the external or general environment. So this is the basic introduction of greenhouse plant. Okay, so the greenhouse, they have told us that greenhouse is the air or environment controlled house in which climate and weather is controlled according to the plant production, according as suitable to the plants. Also the solar radiation are attracted towards the plants. They are the roof coverings or the coverings are used transparent, so as to get the maximum sunlight, so as to carry out the photosynthesis process very properly. Also the structure should get heated day during the daytime, and also insulated during the cold nights. Okay, a greenhouse also acts as a barrier between the plant production areas and the external or the general environment. Okay, so this was the introduction. Next, so location of greenhouse, this is the main aspect of this lesson. Okay, so location of greenhouse, I'll read it. Selecting a good site for the location of greenhouse is crucial. But what constitutes a good site? There are several things that should and must be considered in order to increase the chances of a successful operation and business. Okay, so first, things to consider while selecting a greenhouse site. First, solar radiation. Plants require sunlight for photosynthesis. When plants experience cloudy days, their photosynthetic rates and therefore their ability to grow and yield a product such as tomatoes, cucumbers, peppers, etc. will be reduced. Therefore, a region and location with high light intensity year round is desired. So, location of greenhouse is a very important factor while uh, building or while constructing a greenhouse, so as to have the this is the important aspect which directly reflects on the production or on the environment of the greenhouse condition or environment. Okay, so it need to be investigated or given the more importance. Okay, so first point are there are many factors we are going to study. So there is a first factor, so that is solar radiation. So plants definitely require the photosynthesis for their day-to-day production power or their energy. Okay, so they require maximum sunlight from the sun. Okay, so during the cloudy rates or during the non sunny times, the plants or the crops experience less sunlight, which can affect the yielding. Okay, yielding of the yielding of the crop or production capabilities. Okay, so the so region or the location for this greenhouse must be in a non-obstructive area, or in a in a location where there is maximum sunlight or there is proper ventilation for the night, or proper ventilation during the daytime, as to get the maximum sunlight. Okay, so second is water. Water quantity and quality is crucial. Water will be needed for irrigation, maximum 1 gallon per plant per day for tomatoes. Water will be needed for the evaporative cooling system and can equal or exceed the irrigation water amounts 10,000 to 15,000 gallon per acre per day. In the past, excess irrigation and bleed of water from the evaporative cooling system was allowed to run off into the ground. adjacent to the greenhouse with a minimum percolation rate into the soil of 1 inch per hour. However, due to more strict regulation and desire to avoid groundwater contamination with high concentration of salts, large greenhouses are now recirculating the nutrient solution. Recirculating the nutrient solution also saves water, nutrients, and money. Therefore, excess nutrient solution should be recycled or mixed with the cooler bleed of water and redirected into the designated areas such as grass, shrubs, trees, windbreaks, etc. So here they have told us to use or to make optimum use of water so as to have a proper irrigation system for the greenhouse, as there's this water is needed for the evaporative cooling system, okay, for the greenhouse, as the amount is required 10,000 to 15,000 gallon per acre per day, okay. Excess irrigation and bleed of water from the evaporative cooling system was allowed to run off onto the ground adjacent to the greenhouse. Also, they have stated that this excess irrigation water and the bleed of water from the cooling system, evaporative cooling system, is allowed to drain off to the ground, okay, at the percolation rate of 1 inch per hour. Due to more strict or as per the more regulations or rules are made, they have started to avoid the groundwater contamination with high salts, because those results in higher salts and those can't be used for the proper production, proper utilization of the irrigation water, and those results in uh, not good performance. Those doesn't give the good results in the production or in the yield of the crops, okay. So they have told us to just recycle or reuse the water so as to make the proper use of water, okay. Third is elevation. Elevation will affect the summer maximum and the winter minimum temperatures. Choosing an appropriate elevation will minimize heating costs in the winter and cooling costs in the summer. So elevation, the third factor they have told us for the for to look is elevation. Eleva- Elevation is elevation for the proper orientation of greenhouse is the main factor for the which affects on the yielding and production of the crops. So yielding, sorry, so the proper elevation plays a vital role in the gaining or maintaining the environment inside a greenhouse. So the temperature or the cooling system or the heating systems are all related with the external environment or external solar radiation. So elevation should be in such a orientation such that the maximum heat is accumulated or maximum heat is attracted in the cooling days, and also in heating days minimum or the proper uh, cool or cold wind is blown during the heating areas or during the sunny days, okay. So that should be proper balanced or proper utilized, okay. Next is microclimate. Latitude. Unless the global climate changes drastically, sea level at the poles will be colder than sea level in the tropics. Hence, latitude makes a difference. So here, fourth is microclimate. So climate seasons has a very drastical effect on the environment. Okay, so or environment of the greenhouse. So as they have stated that there is a temperature. Sorry, there is a environment gap or environment change in the regions like poles and tropics. So poles are more colder than the tropics, where latitude is a main factor. So where greenhouse when location is to be considered, so it is also important factor we should look for, okay. Large water bodies, okay, will tend to moderate the temperature. Coastal areas to tend to have smaller day night temperature differences than inland areas. So this is a factor where this factor is looked where the coastal areas is considered where the smaller day night temperature differences are made, okay. Inland areas or uh, the areas where these types of problems are occurring. Okay, trees, mountains, or other obstructions may cast shadows on the greenhouse, especially in the morning or afternoon hours. Mountain can also affect wind or storm patterns. So, where if there are trees, mountains, or any other obstruction near the greenhouse, they may influence in the cold wind blowing or hot wind blowing, or they may also uh, cause the what we can say that the precipitation process, which can affect into the maximum rainfall, or maximum we can also say the obstruction of the wind, or obstruction of the uh, any type of wind, that may be hot wind or that may be cold wind also, it affects the greenhouse structure. Okay, then clouds and fog. Not that certain areas on the lee side of certain mountain ranges or near coastal regions may develop clouds or fog during certain times of the day or year that will reduce potential sunlight. So clouds and fog are also the reason which are affected by which affects on the crop, okay, in the greenhouse, as it in turn affects the inside indoor temperature of the greenhouse. Okay, high winds can suck heat away from the greenhouse and therefore increase the heating energy needed to maintain the temperature inside. High winds can also cause structural damage to greenhouse. So high winds can also blow away the heat away from the greenhouse, so as to which are required to maintain the temperature balance. Also, it may, if the speed of the wind blowing is very much high, then it may cause a structural damage to greenhouse, which may result in the destruction or breaking of the structural members of the greenhouses. Okay. Next is blowing dust, sand. High winds can kick up dust or sand, especially in desert regions, which can damage some greenhouse glazing. So, blowing of dust and sand can affect the glazing material or glazing uh, parts of the greenhouse structure, which can affect in which can affect in the non working of the glazing area properly. Glazing part is required to attract the sun radiations or solar radiations, which can then be affected after this blowing dust or sand. Okay, then snow. The weight of heavy wet snow on greenhouse could crush it. However, high winds in snow areas can also blow snow up against the greenhouse structure and cause damage to it. This danger can be reduced by using windbreaks, trees, snow, fences. So snow is also a main factor while affecting in on the greenhouse structure. Okay. Next is pest pressure. Choose a site away from existing agriculture production areas which could harbor insect pests in the fields. Insect pests of concern include whiteflies, aphids, spider mites, and thrips. So pest pressure, or there are some if the site has various types of grass area below in nearby it, or it has any waterlogging area near it, there may be the danger of the insect nearby to the greenhouse. Okay, white flies or maybe spider mites, or maybe harmful insects which may affect the greenhouse plants. Okay, 6, level and stable ground. The ground upon which the greenhouse will sit must be graded for routing surface water to a drainage system or a holding pond. Typical grade is equal to half percent or a 6-inch drop over a distance of 100 feet. So this is the ground surface on which so they have told that the ground surface must be having a proper surface or proper balanced surface, which can which can be used for proper drainage system, holding pond system, or for the runoff of the excess water which is passing through the roof of the greenhouse. Okay, so that is to be done proper way, compacted, so there will be no settling after the greenhouse has been constructed. So next is utilities. Availability of utilities should include telephone service, three-phase electricity, and fuel for heating and carbon dioxide generation. Note that when compared to propane, electricity, or fuel oil, natural gas is fairly economical heating energy source. However, as fossil fuel costs increase, alternative energies may become more cost effective. Roads need access to good roads to transport the product. Good roads close to a large population center or to brokerage center aids wholesale and retail marketing. Greenhouse orientation. In freestanding greenhouse, more sunlight is available in winter in east-west oriented greenhouse. In multi-span greenhouses, gutters should be oriented in north-south. In naturally ventilated greenhouse, the ventilator should be open on the leeward side. A freestanding greenhouse should have its long axis perpendicular to the wind direction. So here, utilities, they have told us to have the area of the greenhouse such that the maximum utilities can be available in no time, such as the three-phase electricity, telephone services, or the fuse that is required for making or maintaining the temperature inside a greenhouse, that is propane, electricity, natural gas, whatever may be. Also, they should have proper roads nearby it so as to transport the good, or so as to transport the products which are needed for the retail marketing or wholesale. Okay, then the greenhouse orientation should be proper such that the more sunlight is available, proper ventilation is available, naturally ventilated um, air should be obtained for to the greenhouse in for long span for long time. Also, standing greenhouse should have its long axis perpendicular to the greenhouse so as to keep the greenhouse cool during its sunny timing. Okay, so next, capability of expansion. Purchase more land than you anticipate using in the beginning so that you have the ability to expand your operation. Locate the initial greenhouses such that future expansion will utilize the land area most efficiently. Availability of labor. The grower needs people who will want to work as laborers and are trainable to become a retainable workforce. Such skills included pruning, training the plants, and harvesting, packing the fruit. Specialty labor will include people with additional training in such fields as plant production, plant nutrition, plant protection, insects and diseases, computers, labor management, marketing, etc. These may or may not be a part of the regular workers, but may be called on as consultants and as needed. Okay, so they have told us that in capability of expansion, you should, or a work or a grower should have a large area booking so as to in future it may require the expansion of greenhouse structure. It may require for any purpose. They may require for instrumentation. They may require for any further expansion of greenhouse structure that may be required for any purpose. So you should have a proper expansion of greenhouse or area. Okay, also they have told us that labor should be skilled or trainable, that they may require to have the skills of packing or harvesting the crop, or they may have additional training like plant production, plant nutrition, or maybe some operating some computers, labor management, marketing. So they should have a semi skilled labors they may require. So you should hire a semi-skilled. You should hire the semi-skilled laborers uh, for the labor work of your greenhouses. Okay, so so next is management residence. The grower manager residences should be close to the greenhouse so that they can get to the greenhouse quickly in case of emergency. Then community profile. Prior to selecting a site for greenhouse construction, the grower should obtain a community profile for potential locations. These are available at the city or area chamber of commerce and contain community background information, location, elevation, history, and weather. Population, employment structure, and labor force information, growth indicators, principal economic activities, property tax information, available properties, financing, transportation, communications, and utilities, government, medical, and educational services. So, in management residence, they have told that grower or manager, which is the main person who's managing the greenhouse, should be residing nearby so as to have any case of quick in case of any quick emergencies, he should be convenient for the uh, accommodation or for the convenient for reaching the site. Okay, community profile, they have told that you should grower should obtain a community profile, or he should have a proper, he or she should have a proper data for the area, for data of the region, which is needed for the marketing, or which is needed for the commerce section. Okay, so these are various points: location, elevation, history, weather, population. These are many factors which are used in these cases. Okay, so this was so this was about the community profile. Okay, next is various components of greenhouse polyhouse. Okay, the greenhouse is a structure made by assembling different parts or components. Each part has specific role in greenhouse structure. It is covered with a transparent material for admitting natural light for plant growth. The main components of greenhouse-like structure, covering, glazing, and temperature control systems, need proper design for healthy growth of plants. Freestanding or ridge and furrow gutter-connected greenhouses are two common styles of commercial greenhouses. The freestanding style is often quinset, which will accommodate many growing situations but presents height restrictions near the side walls. Another presents in height restrictions near the side walls. Another freestanding style is the single gable greenhouse and its many variations. The ridge and the furrow or gutter connected greenhouses are joined at the eave by a common gutter. When several of these buildings are joined, then they are often referred to as greenhouse range. So here you can see various types of commercial greenhouse structures. So this A type is the gutter connected greenhouse. Then this is quinset greenhouse, which has a sloping roof. Okay, which has the uh, oval roof. Okay, then this is single gable greenhouse, which has sloping roof. Okay, these greenhouse structures have the gutter connected greenhouse structure has gutter passage at the eaves. Okay, here in single gable connected also, here they are having gutter passage where the water is passed from this passage. Okay, so next is foundation. The foundation must resist overturning and vertical pressure from structural loads and snow, and should extend below the frost line. Concrete is the most appropriate material for permanent structures. A 2500 psi or greater mix should be chosen when ready mix concrete is used. Unless the grower is constructing a greenhouse without the use of a manufacturer, specific recommendations are usually provided for adequate durability of the foundation. The foundation stage of construction is critical, and consulting with appropriate personnel such as experienced builders is highly recommended. The foundation can be 60 centimeter by 60 centimeter by 60 centimeter or 30 centimeter diameter and 1 meter depth in PCC of 1:4:8 ratios. The vertical poles should also be covered to the height of 60 centimeter by PCC with a thickness of 5 centimeter. This avoids the rusting of the poles. So foundation of the greenhouse they have mentioned. So they have told about the foundation mix, or what must be the dimensions for the foundation. So they have told us that 60 centimeter cube must be the foundation for the greenhouse structure, and the 30 centimeter diameter or the 30 centimeter diameter foundation for the poles should be used, or 1 meter depth of PCC. PCC is the plain cement concrete. Okay, and the ratio for the cement sand water is 1:4:8. The vertical poles should also be covered to the 60 centimeter from the ground by PCC with thickness of 5 centimeter, that will avoid the rusting of the poles. Okay, so this was all about the part one. Okay, thank you.